Alrighty, so now we're going to be talking about the combined gas law. So the combined gas law is exactly what it says on the label. We combine the changes in pressure, the changes in volume, and the changes in temperature. So when we talk about the combined gas law, it's literally like we smush the Charles law and Boyle's law together. So the formula here is P1V1 over T1 equals P2V2 over T2. Pretty straightforward. Top part looks exactly like Boyle's law, and if you ignore the P, looks exactly like Charles' law. Put them together, you get combined gas law. So what we're going to do is we're going to use an example. Now the Mariana Trench is the deepest place on Earth, and some of you may be familiar with the fact that if you put a styrofoam cup outside in the water in the Mariana Trench, it gets crushed because all the air bubbles escape. And this is also why we have to have extremely hard and durable submarines, because the pressure in the Mariana Trench is so great. So we're going to be using an example there. So let's say that we have a swimmer, and he's happily swimming up at the surface of the water. His pressure up here is 1 atmosphere. His volume, let's say it's the volume of his lungs, so it's about 10 liters. And his temperature, let's say, is nice, happy 22 degrees Celsius. Okay, 22 degrees Celsius is relatively close to room temperature. So now we bring him down to the bottom of the Mariana Trench. So, down he goes. Okay, so now his pressure is 1072 atmospheres. We don't know what his volume is. That's actually what we're going to be finding out. And his temperature has now crashed to -5 degrees Celsius. Okay? So as always, what's the first thing that we do with this? We've got to convert our temperatures. So this one, add 273, which means that 22 degrees Celsius plus 273 is 295 Kelvin. All right? Same thing here. We add 273. When you add a negative, it's the same as subtracting. So -5 plus 273, you get 268 Kelvin. Okay? So now we just need to plug things into the equation. So what's our P1? P1 is 1 atmosphere. So you've got 1 ATF times, what's our volume 1? That is 10 liters, 10 liters, over what's temperature 1? That would be our 295 Kelvin. That whole mess is equal to 1072 atmospheres, because remember that's our P2, times V2, we don't know what V2 is, divided by 268 Kelvin. Alrighty, so now we need to do some math. So we've got 10 divided by 295. So that's 0.0338 ... equals 1072 times V2 over 268. So now we want to get rid of that 268. So we take the 268, we bring it over here, and we multiply this times it. Okay, so one moment. I'm going to use my trusty calculator. So that gives us 9.08 ... is equal to 1072 times V2. Okay, so now we're multiplying here, which means that over here, to get rid of it, we would have to divide, because whatever we do on the right, we do the opposite on the left to get rid of it. So we take this over here, we divide. Okay, so now we are going to divide 9.08 by 1072. So now what we get, and get this, this is crazy, it would be 0.008 0.85. And what's the unit we use? Because we're using volume, we're going to be dealing with liters because we use liters here, so we're going to use liters here. So that is how many liters for V2. Okay? So pretty straightforward, very similar to solving a combination of basically Charles and Boyle's law, because that's exactly what it is. It's the combined gas law. It's a combination of the two. So now what we're going to do is we're going to try one where the temperature is what we're looking for. So let's erase all this. Let's leave our lonely little guy who's going for his adventure. Let's leave him as is. So let's say that he's down at the bottom of the Mariana Trench, and our pressure is 1072. Okay? That's 1072 atmospheres. Our volume, let's say, or better yet, let's actually have him going back up to the surface. So let's have our volume down here, like say that he finds a balloon at the bottom of the Mariana Trench. Not terribly likely, but let's just say something out of a science fiction movie. He finds a ball of air down there. He wants to bring it up to the surface. So this magic black ball of gas that he finds. Okay? So the pressure down there is 1072 atmospheres. We know again it's -5 degrees Celsius, which was 268 Kelvin. And our volume, we know that that's a sphere that's exactly 1.5 liters. Okay? Now the thing is, while he's been underwater, the temperature above has actually changed. So we don't know what our temperature up above is going to be. But we do know that the volume of the sphere when we get it to the surface changes to 10.5 liters. Alright? So here's what we have to do. Once again, we figured out what all our variables are. We're going to just put them in and we'll be good to go. So we start with pressure 1. So what's pressure 1? That's 1 atm times volume 1, which is 10.5 liters. Divide that all by T1. We don't know what T1 is, so we just leave it as is. So let's go to the other side of the equation. So now we've got our pressure 2, which is 1072 atm. That's time our volume 2, which is 1.5 liters. Underneath that all, we're going to have our temperature, which again, remember, is our 268 Kelvin. So divide that all by 268 K. Okay. Now do you see what the problem could be? Temperature's on the bottom again. So what did we have to do with Charles' law when we had temperature on the bottom? Flip it. Flip everything. If we flip the left, we flip the right. So flip both sides. So now we have T1 over 1 times 10.5 is equal to 268 over 1072 times 1.5. Okay? So here's what we need to do first. Remember PEMDAS. Okay? Let's do your multiplication before you do your division. So first we're going to multiply these two together. Okay? So, and again, like I said, this is a little bit more complicated than before. So 1072 times 1.5 that is equal to 1608. So we're going to just erase this and write in 1608. So now we have 268 divided by 1608. See, even we need calculators. That's actually 0.166 repeating. Okay? And this is going to be equal to T1 over 1 times 10.5. Now 1 times 10.5 is just 10.5, so we'll just get rid of this. Now remember, to get rid of what's underneath here, we need to multiply over here. If you're dividing here, you multiply here. If you're dividing here, you multiply here. We always do the opposite to get rid of it. So let's take that 10.5, bring it over here, and multiply. And let's do that math. That means that our T1